Hey guys, welcome back to AlgoYogi. We are now doing array and hashing series, and our next problem in the list is can place flowers. So let's go to LeetCode. You have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots. So given an integer array flower bed containing zeros and ones, where 0 means empty and 1 means not empty, and an integer n, return true if n number of new flowers can be planted. Remember, we have to plant in such a way that we are not planting the flower adjacent to each other, that we need to leave some empty gaps in between them without violating the no adjacent flower rule, and return false otherwise. So simple problem, might have already solved it, but let's go over it again. So we are given flower bed and n, integer n. We need to return true if we can place this many flowers into our flower bed, where one means there is already a flower, and 0 means there is no flower. But if you want to plant this one more flower, so we have this one more flower right here. This just one flower needs to be placed into our flower bed. So if you see right here, if I place this flower right here, then it's possible, this new flower that I'm placing. Why? Because it's possible because I have been able to place this flower in such a way that there is gap here and here in between these adjacent flowers. So these are not, we're not violating any rules to plant these flowers. But if, let's say, if we did not have that, so let's say if this didn't exist, then we cannot place this new flower, right? We cannot place this new flower, since placing this here will violate the rule and placing this here will also violate the rule, right? So if this, in this scenario only, we can only place this. So how are we going to do this? The problem is really simple. We are going to iterate over our flower bed and then check if there is a 0 so that I can place my flower, and I will do it for n number of flowers, So so there are two ways of doing it. One brute force way could be, I will run for n number of times, I will run a for loop, and each time I come across a 0 that is adjacent to other two zeros. So let's say if I were working on this problem, then I would check if for n, so n will run just once, and then I'll check if there is a 0. This one doesn't work because it's not next to, both adjacent side have to be 0. But then I come to this 0. Well, this qualifies because it has 0 in the left side and right side, so that's where I can place this flower. Now n becomes 0. That means I can return true. All right, that's how we will be going to do it. And let's say if in the problem was same, it's just n was given 2. So this n was given to us as 2. Can we do this? Well, actually no, we can only place one flower right here, and no other flower, right? So that is why this will be false. So what we would rather do is, how about just we run for loop on our flower bed, on flower bed, and for loop on flower bed, and find an empty space with, and then keep planting flowers and keep decrementing, and until it's 0 until it's 0. If you can't, then return. It's such a simple problem. I don't know why I'm like, for these simple problems, I don't think we really need to even make videos, but honestly, I just wanted to. Simple to understand. These are the problems that you should be doing it yourself, because solving these problems build like your intuition to, this approach of building intuition for the other complicated problems later we are going to see. So that we can avoid, you can place flowers on the edges if you don't need to check like if you're in the beginning of the flower bed, so you don't have to check like if there is an empty space before it. So for that we can simply just like append to our flower bed. By the way, before that, if the number of plant that I need to I need to place the flower I need to plant, like if that's less than or equals to 0, then I can just return true in the beginning. That's an edge case you can talk about, true. Otherwise I will modify this flower bed so that I'm adding basically 0 in the beginning and 0 in the end, such that I don't have to worry about like checking these edges, right? And then I can start my for loop for I in range. I will start from 1 to length flower bed -1, because I just added these two on the edges. I don't really care about counting there. So if flower bed position, this I is equals to 0, then I want to check two things. The left should be 0 and the right should also be 0. So if flower bed I -1 equals to 0 and flower I +1 is also equals to 0, then I can reduce my n by 1, because I can plant that one flower, right? And if n becomes 0 or less than equals to 0, then I can return true. And I can also return true the same thing if n is less than equals to 0, right? But one more thing, if I'm placing this flower here, that means I want to make it 1. So I will change this value at I, because I'm able to place flowers, so I will change it from 0 to 1. It will be 0, right? I'm checking it, it's 0. So I will place that flower and then I will just move out. So I think that will be all. Let me zoom out. Yeah, and let's run it. And oopsie. So this change right here, we're checking like if n is less than or equals to 0. And I think I forgot to add check if it is equals to 0. Now I think we don't even have to run it. I'm just gonna directly submit it and then write the time complexity. Yep, time complexity here is going to be big of n, right? Where n is the number of length of the flower bed, number of whatever, like. Then we are going to also talk about space complexity. I'm not assigning any complexity. I'm not assigning any extra space, but if you think that we are creating this new flower bed, I'm only just appending zeros in front and the back. So I think you can write it, you can say big of n, but I would say big of 1, because I'm just like utilizing the flower bed. And this I'm doing just only because I want to just avoid that edge cases check. Otherwise you can remove these two from here and then work this whole line from here, and then have these two extra checks for when you are processing the last and the edges basically of this flower bed. All right, so I'll just go back to AlgoYogi and mark this problem solved. By the way, I got rid of that problem where I would check it, mark this status done, and then it will uncheck until you mark it true again. So I'm done. I removed that problem. I was just being lazy. All right, so let's see you in the next video.